I can welcome Sean Powers, fantastic gentleman. He was formerly the editor of Linux Journal. He's also done all sorts of training stuff. I think he has computer-based training and such. He also has a fantastic online comic, of which I am completely blanking on the name. Go ahead and unmute yourself, please. Thank you.
It's My Big Round World, but I haven't been able to make any new comics since I had COVID like a year ago, which just bums me out. So
But there's a
it's
backlog. There's
there.
an archive.
There is a backlog. There is a
Yes,
backlog. Yes.
yes, and I have stickers on my laptop for it
Awesome.
because it is adorable. Anyways, without further ado, I'd like to welcome Sean.
Hello. I'm not really going to share a screen, so I don't know if I need to do anything to, uh, like, to do like somebody pin me or something. I don't even
I
know.
will pin you. Let me do that. Let me see if I can
Okay.
pin you. Pin
Ow.
video. Yeah, there you go. Yeah,
No,
hope it
just
didn't hurt too
kidding.
much.
I don't know. I think maybe you can only pin it for yourself. I really don't know. Maybe I
Well,
present. Can I present? No, share screen. I don't have a screen to share.
you know what I can do. I can turn off my video and I can turn off other people's videos.
Yeah, I don't know. I mean, yeah, tell me what you'd like me to do. I mean, I didn't think this part through.
Well, nobody does. Nobody expects
All right.
this.
Well, I will pin myself on the screen so I can see myself big.
There
Everybody
we
might
go.
just have to pin me big if you want to see me larger than life. Anyway, hello. Should I just start? Should I just go?
Please
Do my
go
thing?
for it.
All right. My name is Sean Powers. I know I was introduced. I just so the last time I was here, I talked about SSH. And one of the things you can do with SSH is do like an ad hoc sort of VPN using a program called sshuttle. Um, but it's not really a full-blown VPN. And if you've been in IT for a while, you've used VPNs. You probably use a VPN every day. I have used VPNs for a very long time. I manage data centers all around the country, and so I have to VPN into them. But recently, VPN has come in the news, and not like privacy VPNs. I don't mean like the like NordVPN or all those things you see like sponsorships on YouTube videos. I mean specifically to get into a particular IP address, like your home or your data center or your office or whatever. But it's come up recently because Netflix is changing how they are allowing people to share accounts. Now, for years, and this is, I mean, whether you agree or disagree, that doesn't change the underlying tech I'm going to talk about. But, for years they talked about, oh, sharing is loving, loving is sharing, and, share accounts. But now they are locking down so that you can't share an account outside of your home IP address. And it's not clear exactly how they're going about doing it. Like, you have to like have a specified home IP address that they auto detect, or it's possible you can specify where your home IP is, and then you have to connect your Netflix client from that IP address every so often, or they'll kick you out or charge you extra. I don't even know. But nonetheless, people are wanting to know how they can set up a VPN. The innocent example of which is you have a child off at college and they've been using your Netflix account in their dorm room because they're in your family, but they just happen to be at college. And so a lot of people are trying to figure out how to set up a VPN so they can VPN to home to watch Netflix. And one of the most popular ways to do that is something called Tailscale. And I'm not going to talk about Tailscale right now because while Tailscale is, honestly, it's amazing. I am going to talk about it a little bit later, but Tailscale, their underlying technology that they use is WireGuard. Now, WireGuard is a completely open source VPN technology, but the cool part about WireGuard is its simplicity. It reminds me a lot of SSH, meaning there's, well, like SSH, but even stripped back a little further, there's no username password authentication involved with WireGuard. It's all public-private key pairs to connect peers together. And there's only a single port that has to be forwarded in, and even that only has to be on one computer. It is just an extremely efficient, secure, awesome technology. And it's a little confusing at first, but once you understand what's going on, the simplicity is just it's awesome. So that's what I'm gonna talk about tonight. Now, I do have a full length YouTube video. It's like 40 minutes long. I'm gonna play some snippets from it because I didn't want to reset up my whole lab environment. But I'll make sure there's a link. So if you want to watch my whole video, stem to stern or rewind or whatever, you can do that. But I want to talk about how to configure WireGuard, even if you don't end up using it. And here, let's get closer. The thing about something like Tailscale, it's a lot like DevOps. And if you've used DevOps at all, you're familiar with things like automation and configuration management. But one of my overarching rules whenever I teach about DevOps or introduce somebody to DevOps is that you should never automate something that you couldn't do manually. And for many, many reasons, but I really don't want people to use like Tailscale as this wrapper, but if they don't really know what's happening under the scenes, if you're an IT person, and if you're watching a mug meeting, you're a tech person. And so I'm going to show how WireGuard itself actually works under the covers. Even if you're using Tailscale, you're actually using WireGuard. So let me look at my notes, make sure I didn't miss anything. No, let's go to the slides. So down here, I'm going to shut off my face. Well, shut off my face. That doesn't sound great. I'm going to turn this off so you can see the whole thing. And I was told that the color scheme is not super readable. And for that, I really, really do apologize. But basically how WireGuard works, if you're familiar with VPNs, this won't be anything new. But here's the situation that I'm going to set up in sort of partial real time using some video clips, etc. This is the remote me, right? This is me at my house, and my IP scheme inside my network is 192.168.1.0. Okay, /24 means that it's a 24-bit subnet mask, and basically this last digit 1 through 254 can iterate all the IPs inside my network. But this is not an IP subnetting class. So this is my home, and actually it's literally what I'm using here in my home. Now, of course, I have a connection to the internet, but what I want ultimately is to be able to connect to my personal data center. I have a farm, it's a literal farm, and then it also has a data center built in with, commercial class fiber gig up and down. It's really, really sweet. But this is where most of my services, like I host my own email and web services, and all the stuff that I host is going to be in my little data center. But I want to be able to just connect to this IP scheme from my house. And of course, there's a public IP there as well. Basically, at the end, I want to have any computer inside my network here at my house to be able to directly connect to any computer inside this remote LAN. And to do that, I'm going to just set up a WireGuard peer connection. Now, it's important to note with WireGuard, there really isn't a server client setup. Sort of. Every computer in a WireGuard network is called a peer. And unfortunately, in order to set something up, we generally have one of the peers that is set up as you would traditionally think of a server. Like, it has a port forwarded in it, and it's listening for incoming connections. But there really isn't a server client relationship. It's just the peer that happens to be exposed to the internet with a port forward is how you initiate that connection. And then the peers can talk amongst themselves. They're literal peers. There's not like a master and the client is connected to it. It's a peer environment. But I'm going to set it up, and I'm probably going to misspeak, and I'm going to refer to the computer in my data center as the server, because that's mentally how I have to think of it. Like, my client is my home, and I'm connecting to the server at my data center. And so just know that WireGuard doesn't consider them servers and clients. It consider everybody peers. But in my head, it it's going to be like a server type thing. All right, so clear this. Okay, good. Now here, yeah. Oh, look, I had a slide that said that exact same thing. So there's no server exactly. However, yeah, I'm going to set up the server at my data center as a peer. Now, in order to set this up, remember, this is the remote data center's IP range, 192.168.5 dot, whatever. This is my home range, 192.168.1 dot whatever. When you set up a VPN, and this is not unique to WireGuard, you generally have a tunnel set up, and this is where all the traffic goes through, back and forth. And usually that tunnel will have its own subnet, and this is no different. The tunnel IP range that I'm going to use to set up is 10.10.0.0/24, which means, again, this last number is what will iterate, and all of the tunnel ends will have an IP address in this range. So in order to set up WireGuard, again, they're both peers, but I'm thinking of this as my client at home, we have to have a public key and a private key. And in order to establish the connection, each computer has a public key and a private key, and they share the public key with the peer. So they send their public key to the other side, and that is how they know that they are connected to the correct person, and that's how they authenticate, is with this public-private key pair, and they send the public key. Never, ever, 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 ever will you send a private key to a remote computer. That's just true across the board, right? You just never send your private key. Your private key always stays on the computer. So you can share your public key, never your private key. That stays true with WireGuard. Anyway, with all that said, there is another layer of security that WireGuard supports, and that is a shared key. And a shared key is just that. It's a key that we generate, and each computer or each peer has the exact same key. So obviously the public key of this computer is going to be different than the public key of this computer, but the shared key that we create is exactly the same on both sides. Okay, so this is hopefully this makes sense. This is the way in which WireGuard authentication works. And as we set it up, I'll show you how the routing aspect works. But this is what we need. We need a public key, a private key, and we need to know what the tunnel IP range is. And then we need a shared key if we want to do it. I'll set that up, but it's not necessary. If you don't have a shared key, you just don't include that information, and it still works just fine with just a public-private key pair. Okay. So now I'm going to play a video clip because, like I said, I didn't set up the VM that I have. Hopefully the video clip will just work. Just know that even though it's me talking, you'll tell that it's not live me because in the video, my hair is not green. So what we're going to do in this video is show how to generate using WireGuard. Now, I've already installed WireGuard, and it's just like apt-get install WireGuard or DNF install WireGuard. It's going to be in every distribution out there. And again, since there's no server or client, it's always the same, right? It's just you install WireGuard and then you're a peer. And then your configuration files determine how exactly it works. But install WireGuard, that's all set up. And then we'll walk through how to generate those keys, right? The public and private key pair for each side, and then even a shared key. So here's the video. Hopefully this will work. I did test in advance, but no guarantees. We'll try it out. Server. The first thing we're going to do is generate the keys. Now you can save these to files, and that makes sense so that you have them backed up on the computer itself. But I'm going to go into the etc. WireGuard folder, and there should be nothing here, completely empty. We're starting from scratch. And I'm going to say WG for WireGuard. That's the WireGuard main command line thing. I'm going to say gen key, okay? And it will spit out a private key. Boom, that's my private key. Now we could put this in a file and save it. I'm not going to do that. I'm just going to copy it, and I'm going to paste it right there. Let's see if we can stretch this a little bit. so we can see the whole thing. Okay. And now in order to make the public key, you actually have to use the private key to generate the public key. So what I'm going to do is it's still in my clipboard. So I'm going to say echo, and I want to have it echo that key. Okay. So if we do that, it will just echo it to the screen, right? So I'm going to say echo that and pipe it using the pipe symbol. So I'm going to redirect it into standard input of the command WG pub key. Okay. And that will return the public key to us. So now this is the second thing we need to keep in our notes. We've pasted it in there. Now we can do the same thing. Should we generate the pre-shared key here? I mean, we might as well. It doesn't matter where we generate it. It's going to be the same on both. To do that, we do WG gen pre-shared key. So gen for generate, and then PS key or PSK for pre-shared key. Press enter. This is a pre-shared key. So we're going to take this, we're going to paste it over here. Okay, and that's our pre-shared key that both computers will have to have. Now, before we do anything else, let's come on over here. You notice I switched tabs. Now I'm on the Mate computer. We're going to go into etc. WireGuard. Nothing in here again. The reason I'm in here is this is where the configuration file is going to go, but we didn't necessarily have to be here to generate the keys. Anyway, I'm going to do the exact same thing. I'm going to say WG gen key. This is our private key for the client side. So I'm going to take this, so paste that in there. And now the same thing, I'm going to say echo what we just had. So it's still in the clipboard. Okay, that's our private key. I'm going to echo that and then pipe the output into the standard, into the standard input of WG pub key. And that will give us the public key. Going to paste that into our little document over here. And that's all we need to do. Now we just need to set up the configuration files. And I didn't have to generate a pre-shared key because remember, it's the same for both. We already have it. So I didn't need to generate a pre-shared key on this computer. We generated it on the other one. All right. Hopefully everybody heard that. Is it clear? And I will take your silence as affirmation. What we're doing here, we're actually just, I had a text file keeping notes of like each private key, public key, and the pre-shared key. So now we can set up the configuration files on each side, like our two peers, and I'm treating the one in my data center as the server, and then the client side here in my house, I'm treating as a client. Again, they're all peers, but they're going to be acting in that way. So hopefully that's clear. And then the next video is, I think we are setting up, hold on, let me look. We'll just look together. I think I'm setting up the the server's configuration file. So the server is called WireGuard. And so when you see WireGuard, that is the server side in my data center. Oops. Oh, that's not what we're going to do. Okay, let me switch over. All right.
I think the audio is not working at the moment. It's not
configuration file. I'm going to call it WG0. So let's set up our server first, I guess. Come over here. And I'm in the etc. WireGuard folder. I'm going to create a configuration file. I'm going to call it WG0.conf. It doesn't have to be named this. This is kind of the standard default is WG0 for WireGuard interface 0.conf. On the server, I generally like to keep it that way. I like to call it WG0 just because it's the standard and it's going to be listening. And so I want it to be server like, and I don't know, you can name it whatever you want. I just always use WG0 on my server side. So this is going to be just an empty document. And the first thing we need to do is set up the interface itself, like the part that's going to be listening. Like we need to set up this peer's information. So we do interface, which is, this is like a section. So it's in brackets. And then we have to tell it a couple things. One, the interface has to know its private key. So we're going to say private key equals, and then we're going to take the server's private key right here. We're going to copy this, the whole thing, and then bring it up here, paste it in. And now we have to tell it the address that it's going to use. And now remember I said that the VPN tunnel has its own range? That's what this address is talking about. This is not the computer's address. This is the WireGuard interfaces, like this end of the tunnel's address. So I'm going to say address equals, and it's going to be 10. What did I say in the thing? I think it was 10.10.0. something. And so I'm going to make this 10.10.0.1. And I'm going to say /24 for a 24-bit address. And so this end of that VPN tunnel is going to have the address of 10.10.0.1. All right. And then we also have to tell it what port to listen on for incoming connections. Remember that port forward we set up? So that is going to be listen port equals, looking up at my notes here, 58123. That's the port that I forwarded into this computer from the outside world.
Okay, yeah, and I forgot to tell you about. So basically, like I said, the one side, in my case, the server side on the in my data center has to have a port forwarded in, and it's a UDP port, and I chose port 58123, and that's forwarded into the computer that we're configuring here. It's, I think we talk about it, but it's like 192.168.5.37 in this case. Remember, it's in that same range, in that 5.5 range, and so that is the port that is forwarded in to my computer. Now, I skipped over the part where I set up routing. And again, I'll have a link to the full video if you want to see me set up this whole thing from stem to stern. But basically, if you have done any routing with a Linux box, like, 2 Ethernet ports and use it as a router or whatever, there's a couple things you need to configure. You need to configure the kernel to do IP forwarding. And so that's like in the sysctl.conf file. You just turn IP, it's like net.ip4.forward or something like that. IP forward equals 1 to turn that on. And then we have to set up some IP tables commands to do masquerading if we want to be able to use this server as a way to get to the entire network. Now, we don't have to set up like IP tables and IP forwarding if we just want to reach this remote computer, right? If it's just a peer all on its own, they'll be able to talk over that tunnel that we set up to each other. But my goal is to get to the entire internal network. I know one of the folks talked about that before the meeting started, whether you do it on your router, or in this case, I'm just doing it on a computer inside my network, and it's still going to be able to forward to the rest of the network inside, even if it's not done on the router. And so that's what we're doing. So there are IP table stuff that has to be set up. I'll give you a tip my hat a little bit, or to the future. There's a simple website that shows you how to do everything so simple, and we'll look at that too. But just know that all that forwarding stuff is set up with IP tables. So the next video, you're going to see a whole bunch of IP table stuff put in there, and that is just so that the routing will work. So we've set up the interface on our server side, but now we have to tell it about its peer, right? Who's going to connect to it? We have to configure the peer in my house, which is going to connect. So the server side of the peer configuration is what we're going to look at now. Maybe. Oh, okay. Almost there.
The only thing we need to do is set up our peer connection. Like, okay, we're listening. We have rules set up for when we're listening, but who's going to connect? And that's where we have to define the peer. Now, in our case, the peer that we're defining on the server is our remote virtual machine, Mate, right? That one that we're going to set up, actually this computer that we're on, but we're SSH'd into the WireGuard server. So we need to set up a new section, and this one, I need to hit enter there. And it's just called peer. Now you can have multiple peers configured. You just have a new peer section. So peer, 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 peer. And what I like to do is comment what the peer is in case there are multiples. So anything that starts with a pound symbol or hashtag for the new kids is just a comment. So you can describe in here. So there's going to be the VM at my house is the peer that we're setting up here. And then to define the stuff that we need, first of all, we have to tell it
the private, or not the private key. We have to tell it the public key of the peer, remember, because we're going to tell the other side our public key. And in this case, the client over here in our notes, the client's public key is right here. And this is how the server is going to identify the incoming peer. So we're going to say public key is equal to, and then we'll paste that in. And then we have to tell it the address of that peer. Okay, so the peer's address. But since we're talking about another peer, we're going to say allowed IPs. And this is a little bit confusing terminology because, again, every server is a peer, every peer is a server. But the allowed IPs are basically what is this computer, our server, what IP addresses is it going to use this peer for? And it's going to be that peer's IP address because it wants to talk to the peer on the peer's IP address. So the allowed IPs in our case are going to be 10.10.0.2. We're going to use .2 for our peer. And then we're going to do /32, which I know is different from the address that we set for the interface itself on the server. But what this is, the /32 means only this IP address. And the reason on the server we say only this one IP address is who we're communicating to this peer through is because if we have multiple peers, we might want another peer to be 10.10.0.3. And if we were to say that all of the traffic going to 10.10.0.2/24, like the whole range, it would send all the traffic to the first peer, and the second peer, it wouldn't. So by limiting it to saying only this single IP address, and that's what /32 does, limits it to a single IP address, that means that only the peer's IP address are what's going through the tunnel to that peer. Hopefully that's not too confusing, but when we set up the peer, we want to just have it go to that single IP address. And then even though it's optional, we did create a pre-shared key. So let's put the pre-shared key on this side of the connection. So we're going to say pre-shared key equals, and then we'll just copy and paste this pre-shared key in our notes over here. And then we're going to paste that in. So our pre-shared key is listed right there. And okay. And so that's actually all there is to set up on the server side. It knows that it's going to have an incoming peer, and that incoming peer will prove who it is because it's going to use its private key to do a handshake with the public key that the server now knows about because we put it in that peer section. And all that's left now, so that's all set up. So we'll start that service, and then we will head over to our client and set up the similar thing, but with a slightly, different twist to the client config. So that's how the configuration on the server is all set up, and hopefully we'll be able to go from here and do the next section. Uh-oh. My computer has locked up. Wow. This is
it wouldn't be a live demo. It wouldn't be a live demo.
Right. I mean, I did this so that I wouldn't have a live demo go wrong, and this is what I get. No, that's not it. Oh yeah. Page is unresponsive. Yeah, it is. Let's see, where were we? Okay, well, and you're hearing me, so it's not like my internet connection died.
No, we're good.
All right, well, let me take this off the screen. Here, you can stare at my face as I puzzle why my presentation quit working. I'm using Canva because I wanted to be able to play videos, and just completely failed. Can't even close.
Let's take some questions if we have.
Yeah, if there's any questions, if somebody else answers them because I'm distracted, that's okay. No. Any questions?
Does this work on Mac and Windows?
Yes, absolutely. There are really cool little GUI clients even for Mac and Windows. It also works on like iOS and stuff, which is just pretty cool too.
Yeah.
And Android.
And yes, an Android. Well, of course, that's Linux, right? That's why I didn't say it specifically. Gosh.
Oh yeah, totally.
All right, let's try this. We'll try this again. No, not share. Present. All right. Yeah, that. Oh, you're not seeing this, huh? Yeah, that was my note to myself. All right, I think we're gonna be good here. Oh, come on. The only thing we need to do is set up our peer connection. So now we're going to go over to Mate, which again has nothing set up yet, right? We don't have anything set up. So let's create a file first of all. And I'm going to call this one, the data center's at my farm. So I'm going to call it farm0.conf. Okay, that's what I'm going to name this interface as farm0, and we'll edit it from here. Now, again, every peer is a server, every server is a peer. So we need to start with interface, and we're defining this computer's interface. Okay, so the first thing we're going to do, and it doesn't matter what order you put these things in, but we're going to do private key equals, and we need to give it its private key, which we generated and we saved over here. So this entire thing here, fix that in. Okay, so that's our client's private key. And now the address that this interface is going to use, 10.10.0.2. Okay, remember, because this side of it is .2. The first client is .2. And I'm going to say 24. I want it to be able to communicate anywhere on this subnet. And so I'm just like I did on the other side when we set up the interface itself is going to listen on all the entire subnet. So /24, this is its IP address. And then since we're not doing any routing on this side, that's it. All we have to do on this is have its private key and its address, and that's it. Okay. So now we need to set up the peer that it's going to connect to. So same thing as the other side, peer. I'm going to say data center at my farm, again with that hashtag symbol at the very beginning. So it's just a comment. It's not parsed by anybody but our human eyes. All right. And then public key of the server, right? The public key of the server, which is right here. Paste that in. We can put the pre-shared key in now. Again, it doesn't matter what order the things go in. So I'm going to say pre-shared key equals, and it's the same pre-shared key that we used on the other side. So this is our pre-shared key. Copy that. Something we need on this side that we didn't have on the other side is where are we connecting? And that's actually called the endpoint. Endpoint equals, and this would be the public IP address that is at the data center. Right now I actually have it's called just remote.ip, but this could be like a public IP address. Right, this resolves for me to a public IP at my data center, and we have to tell it what port that we're going to use. In our case, it is, what was it, 58123 was the remote port. So this could be like a remote IP like 1.2.3.4, whatever the public IP is, or a fully qualified domain name. And that's what this is for me. This is a domain name. Remote.ip is the remote, is the public IP for my data center, just so I don't put my actual IP on here to show everybody. So that's the endpoint it's going to connect to. And then we also need, for remote computers that have to tunnel through an outgoing NAT, I like to actually have a persistent keep alive setting, which basically just, it's not really a ping. It just like rehandshakes the remote server every so often. And I like that because while on the remote side, the server has that forwarded port, on my side, when I go out to the internet, that could expire between things that I send to the data center. So I want to keep this NAT on my side, or at the coffee shop, or wherever we happen to be. I want to keep that alive. So on the client side, I usually make a setting, persistent, I'm gonna make sure I spell it right, persistent keep alive equals, and then how many seconds before, just like send a quick ping. And it's not an actual ping, but like a quick connection to keep that tunnel established. I'm just going to say every 25 seconds, just send a quick keep alive packet. And then last but not least, what do we want to use this peer for? Right? We want to connect to 192.168.5 stuff. So we have to define that. And on this side, it's going to be allowed IPs equals, and so we say we want to use this for 192.168.5.0/24. So that entire range we want to send through this peer, because that's the only way we're going to get to it. And now we also need to do one more thing, is we need to say, I want to use this peer for the tunnel, right? I want to get to the tunnel itself. So we also have to say 10.10.0.0/24. So that whole network, we also want to send through the peer connection as well. Now, I'll admit, sometimes, depending on your server side, you may not need to specifically mention the peer, the tunnel address itself, but it's always safe to do that. And I always recommend that you do put the tunnel IP in there, because sometimes it will fail if it's not listed in there. So sometimes it'll work, sometimes it won't. It will never hurt anything to have the tunnel IP in the allowed IP range here. So I just always put it in there. And then that's really it. That's all there is. Let's save this side. And now same thing on this end, we can just say WG quick up, but on this side, no, it's farm 0. We'll press that. And now it should just work. So let's try it. Let's come on over here to, we're just on the VM. And if you remember at the beginning of this video, 18 years ago, I did a ping 192.168.5.37, and it failed because we weren't on the same network. But now it should just work. And look at that. So we're able to ping and connect just as if we are on that network, because it is set up through this WireGuard tunnel that we have established.
And so that is it. Hopefully, hopefully that wasn't too confusing. Like I said, the full video, I'll make sure there's a link to it. But the once it's set up and both sides are started, it just works. And the cool part is, if you don't try to connect to that, remote server's interface, it just never sends any packets at all unless you have that persistent thing set up, which is why I do that when I'm in a client, because I want to make sure that the state is established. And sometimes it gets wonky if you do something on your client and then don't do anything for a while, it'll kill the state. And then when you do connect, it'll be a different state and like you'll error out and stuff. So I like to do the persistent connection when I'm setting that up. Now, in order to get it to start automatically, there are systemd startup scripts that you can have it automatically come up, on the system boot, like on the server side. You saw me use the command line tools to bring the interface up, and you can do the same thing to bring the interface down. I will often just have it automatically go up and using the systemd script, but that allowed IP thing, on the client side, I said the allowed IP, I just wanted it to be 192.168.5. whatever. But if you want to funnel all of your traffic, like if you are trying to like tunnel Netflix to a different computer or whatever, you can say allowed IP is 0.0.0.0, and then everything will get funneled through the tunnel, and that is how you can do it. Now, maybe I mentioned in the little video clips, but all that configuration, it's not complicated, and it's important to understand how it works. But let's no, stop. I want to get rid of this. Here, let's come down here. Come down here with me, and I'll put my face on the screen so you can see me down here as well. If we go to, did I copy it? What is it? WireGuard, guardconfig.com. WireGuardconfig.com is just so stinking awesome. This will, first of all, you can type a random seed here for some extra, what's the word when you try to get more randomness into a system? Entropy. You can type randomness in here to create your own entropy, but basically you just set up like how you want your configuration. So like this is the default listen port, and how many clients are we going to have? We're going to say 3 is fine. We could do 5 or 10 or whatever, and you can hold the extra ones off to the side. The CIDR, this is like the what is your tunnel IP range going to be, and it's using 10.0.0 instead of 10.10.0 I think I used, but this is just the tunnel interface.
client allowed IPs. This is, like I said, if you do 0.0.0.0/0, it's going to forward every bit of traffic through the remote tunnel. And so you can, but you could also just set up like, get rid of this and do 192.168.5 dot whatever it is you're trying to connect to. And then this is the endpoint. So, the server that we're going to connect to, this is its public, fully qualified domain name. And then you have to put the port number, which we defined up here, put the port there. And then you can set up some DNS stuff so that it will use a different DNS server if you tunnel through. So like if you have internal DNS, you want to make sure it gets to. Otherwise, you can leave that blank and it will just continue to use whatever DNS server your system is configured to use. These are the IP table stuff. The only thing you have to be careful of here with the wireguardconfig.com is on your server. Remember, you only have to do the IP table stuff on your server that is going to be like routing traffic. You have to make sure that you have the correct interface name here. Back when all interfaces were ETH0, ETH1, etc., this was fine. But now if it has like, ENPS 0, or, you have to make sure you have the right interface name here. Otherwise your IP table scripts won't work. But so set those up. Everything else should be fine. You can use a pre-shared key. You can check this or uncheck it. It doesn't matter which you do. We'll check it. And then you generate config. And this is the part that's super cool. So you click generate config and voila. Down here, we have all of the configuration files completely set up for us. And all of the stuff is here for us to copy and paste rather than doing all that gen key stuff on the command line. It will completely set stuff up. And it even has a nice QR code. Like if you have an iPhone that you want to set up as a client, you can just scan it in with a QR code. It's really, really nice. But you can use all of this information to configure your server and all of your clients. And if you go to the bottom, there's a place. Where is the place here? Oh yeah, right here, a zip file. You can download the zip file and it will have all of your configuration files so you can store them like in your password database. Like if you have something like Bitwarden or you're using like 1Pass or whatever you're using to store your very private data, and I hope that you have a password management system that you use, you can store these in there. And even if you don't have 3 clients off the bat, you can save them and then you'll have it all configured and your server will already be configured for all 3 of those clients. So it's really, really, really cool. This website, I highly recommend using this. Now that you know how to do it manually, please don't do it manually. It's so much easier just to go to this site and then you get a nice zip file with all of your stuff. Now, before I talk about, I do want to briefly mention things like Tailscale and stuff. Before I do, does anybody have any questions about WireGuard that I can address before I kind of change the subject slightly and talk about Tailscale and Headscale and that kind of stuff?
I have a question. That website you just showed, I assume that probably runs in JavaScript locally, yes. Right? Yeah, it's not.
Yeah, and I did check. I checked to make sure that it wasn't like something they're doing server side, because that would be super creepy. But yeah, it is definitely a JavaScript type thing.
Okay, thanks.
Yeah, good question though, because that would be super creepy if it was a website that's like, here, let me generate private keys for you.
I have a question.
Yeah.
It's a little bit more about Tailscale, but I think it still applies here. I've been trying to set up Tailscale for my mobile phone, but I only want to forward my DNS queries through it to my local DNS. And I cannot seem to figure out how to get that to work without specifically exposing my local DNS publicly.
Yeah, it shouldn't expose it publicly. I mean, it would expose it to the tailnet. And I'm going to talk briefly about Tailscale in a second, but I mean, I don't know how you would just do DNS queries though, without forwarding because I guess you would have to set up on your client. But it's an iPhone client too.
Well, Android, but yeah.
Oh, sorry. Yeah. But a mobile. And because you could set up the tailnet IP, which the tailnet IP is basically like the tunnel IP, like we just talked about for WireGuard. You could set that as the DNS server, but I mean, because it's getting its information via DHCP, it usually, you can in Tailscale set up what DNS services are configured, like just that the WireGuard site that I just showed down here. You know, if we scroll up, this DNS optional information, Tailscale has the same sort of a thing where you can do that, but I don't know how you would just do DNS stuff.
Well, so my first
without
thought,
forwarding.
when I first tried doing this, I thought, well, I should be able to use my Tailscale IP address of my home, you know, the home server side address, and use that for the DNS entry in the Tailnet config page. But it simply does not work. And the only thing I can think of is that it might be looking externally to resolve those addresses, which is why I'm thinking it's possible that it's looking for a publicly accessible DNS server.
Okay, maybe is the
maybe it's a little bit
DNS
weird.
server configured in, you know what, let me talk about Tailscale real quick.
Yeah,
So
okay, go ahead.
if people aren't familiar with Tailscale, they'll, you know, kind of know what we're talking about. Tailscale is it's WireGuard, but the difference is Tailscale uses all, I mean, this isn't different, but Tailscale uses all open source software, save two pieces. They have a GUI client and a web interface that is proprietary. And then they have their control center. I don't remember exactly what they call it, but it's basically, they have in the cloud, a server that dynamically changes the routing protocols that the WireGuard services have running underneath. So it changes like the allowed IP and the DNS settings and all of those things in real time so that you can always connect to individual clients. It will also do some amazing things like set up relays where if you have two computers that are behind firewalls so that they just can't get connected directly using this, you know, VPN, a kind of mesh peer-to-peer thing, they will actually allow a proxied type of relay that will make sure that every computer is accessible. It's fascinatingly flexible in how it does routing. So tailscale.com, you can go there. They have a fairly generous free tier as well. Again, this is a paid system, but it does have a pretty generous pay or free tier, and it works for Mac OS, iOS, Windows, Linux, Android. The nice thing about Android is you can actually configure Tailscale as a client on like Android TV. Like you can get an app, the Tailscale app is in the Android store. You can install it. And then if you're using something like NVIDIA Shield or whatever other Android TV stuff there is, it can actually be a client that connects to a remote computer. And how they set up the routing is they call them exit nodes. And so, and they do it all behind the scenes. It's just so slick. But anyway, so that's how it works. You just download it. They have a nice little installer script. These always creep me out. You probably can't see, maybe you can, but it's just, you curl the installer. It's an SH file. It's a bash script or an SH script, and then it will execute it. If you look at it, and I always look at the scripts before I execute them, basically it just adds a repo to your computer and it then installs Tailscale. And it starts as a service on your computer. So it's not doing anything creepy with its automated installation. All it does is detect like what kind of operating system, what distro you have, that kind of a thing. And so, it does all the things. It also tells you how to do it manually. Once it's installed, now I have it installed on this computer that you see the green background. This is a virtual machine that is running, and I installed Tailscale. Now you're going to see my Gmail account because another thing about Tailscale is they don't have any user authentication on their site. You use a third-party OAuth kind of thing. So you have to authenticate with a third party like GitHub, or I used a Gmail account. And so I downloaded, installed it, and then when I configured it, I just switched tabs here. And so you'll see I have three computers, three machines that have Tailscale installed. Ubuntu Mate is this computer that we are on right here, this green computer. And Ubuntu Mate has an address that's right here. This is only visible to other computers in my tailnet, it's called, right? This is my my tunnel's IP range. And so this is my internal network. Borg implant is my my iPhone. I just installed an iPhone. And then Brutus, this is where my data center is. And I actually installed this on pfSense. pfSense has a really sweet little plugin that you can set up your router as a Tailscale node. And so you can then also set it up as an exit node, so you can route all of your traffic through the remote router. It's just, it sets up all the stuff dynamically. It's actually really, really amazingly cool. And it just works. So I have it turned on. This says they're all connected. And so I'm back here. This is the command line interface for Tailscale daemon that's installed. And so I can say, I kind of remember, I haven't used it much, but I think it's just sudo Tailscale down. And I think that will bring my Tailscale node down. If we look over here, it should, might have to refresh. Oh, I'm offline. Yeah. So there we go. Oh no, why didn't it show that it's offline? Must have cached it, but I'm offline here. If I want to go back online, I can do sudo Tailscale up, and now it will bring my interface up. And the way that we can, you know, test, like, oh, I'm connected. Borg implant is what I called my cell phone because it seemed appropriate. But Borg implant, it automatically sets up magic DNS. So I can do ping Borg-implant, and it will automatically ping my my cell phone. Even if I'm not connected to my local network here, I can be, you know, connected over LTE, and it will just automatically do all of that routing for me. In fact, I haven't, this is another live demo, so maybe this will go horribly wrong. I'm going to turn off Wi-Fi on my phone. And so it stopped, the ping stopped working, but then they just started again. Okay, did you see where like they stopped and then they restarted because Tailscale again rerouted everything and automatically had it working. Now, like I said, this is and that's why I was a little surprised that the DNS stuff didn't work. Let me find my mouse so I can, oh, come here, mouse. Okay, there. Control C. And now you can set up DNS settings. I don't think I'm going to expose any information here. No, this is just the silly tailnet that they allow you to do. And then it should automatically work. It's weird that it didn't for you. So I'm not sure. You can set up name servers here, like add additional name servers. This is where I would expect that you would probably have to do stuff like override local DNS and set up the other name servers and stuff. So it's somewhere in there, and I don't have a great answer for you as far as why it didn't work just out of the box. But that's how it works. Now I do want to show really quickly how we do. Are we doing okay in time? Yeah, I think we're okay in time. I wanted to show, I guess I don't have the pricing download. There we go to pricing. The thing about their pricing, it's a very generous license. You have one user, so it's just like the one Gmail account, but you can have up to 20 devices on your free tailnet that always can see each other automatically, and they'll reroute, like I said, even if the network changes. The one subnet router, this is the, if there's a limitation that you can feel the pinch, what this means is we can set up that exit node, and we can have it forward traffic to our internal subnet, just like we did with WireGuard, right? Like I set up those IP table things, and you can set it up so that you can get to all of the devices behind a subnet, but you can only do that on one with the free license of Tailscale. And you know, everything else it offers is completely free. So it's generally pretty decent for like an end user to be able to do that. But what if you want more? Well, all of the Tailscale stuff is open source, except for that control center that does all the dynamic switching and doing, and the GUI interface, the web interface to manage stuff. You oddly don't do all that much stuff on the web interface. And there is an open source project that takes the place of Tailscale, and it's called Headscale. Pretty clever, right? So if you go to this GitHub page, you can just search for Headscale, and you'll find the this GitHub page. Juan Font looks like is the developer. Basically, what this does, it takes the place of Tailscale's main server, like the server that you authenticate with and the server that manages all of the routing. You can run this like in a Docker container, and you have to expose some ports and like some stun ports and stuff, because again, it really needs to be able to connect to the internet solidly so that it can do all of those crazy rerouting and proxying and relaying stuff. But once it's set up, you can, instead of directing your Tailscale computers to the main Tailscale server, they have options. You could look, hopefully you can see this, with Linux, OpenBSD, all of the clients, even things like iOS, you can redirect it to use your local server instead of this Tailscale server. So you still use the Tailscale client, but you just redirect it to your own instance of Headscale. And you get almost all of the features. There's a feature list here. You get almost all of the features that you get with Tailscale, but you don't get the limitation of the subnet thing, and there's not a limitation on the number of clients that you get, things like that. Now, the last thing I'll talk about is, I won't talk about it much other than let you know it exists. There is also an open source web UI that is very early in development, but Headscale web UI, and it tries to take the place of the Tailscale website, their UI, and you can see all of the information, and you can do some configuration. There's not as much available yet on the Headscale UI as there is on Tailscale, but it does work. And since you use the Tailscale clients to use Headscale server, most of the heavy lifting as far as the client stuff is already done. So once you have it set up, it generally just works. And yeah, it's pretty slick. So Tailscale makes the whole notion of WireGuard very, very simple and almost shamefully easy to set up. And Tailscale itself, you don't have to set up Headscale. Tailscale has a very generous free tier. And so I encourage you to check that out, because yeah, I've tried it and it's amazing. So hopefully that was a helpful presentation. And I don't know where I should put the link. Should I put the links somewhere like in the chat, or do you want them where do you want them? Where do you guys want the links?
Oh, you
can
just
go
sent
to
the
the
chat.
link.
In the chat. All right. So I just pasted in the chat. That's the full video that I did on WireGuard setting it up. Like I said, it's like 40 minutes long.
Okay.
It just goes through, you'll recognize some of the clips, but it's the entire process from stem to stern. And then in the video description on there, you'll see the link to wireguardconfig.com, and then tailscale.com, and just search for Headscale on GitHub if you're a self-hoster like myself. I prefer to self-host things, so I'm definitely going to be playing with Headscale a lot more than I am with Tailscale. But honestly, I have WireGuard set up everywhere, so I don't know. I don't really need to. It's just fun, so I want to play with it. Any questions that I may or may not have the answer to about Tailscale or Headscale?
Feel free to use the raise hand function if you have a question, or feel free to just unmute yourself.
Are there security concerns with using Tailscale versus just WireGuard?
Well, they say no. I have no reason to doubt them, but honestly, that's the reason that I like the notion of Headscale. I mean, it's all encrypted. I don't doubt that, because they use open source tools behind the scenes. So like your traffic is pretty much encrypted, but they are controlling the various routing of your stuff. So, you're putting some of your eggs in somebody else's basket. I don't think it's exposing any data. It just, you know, I mean, they will have the data of your live IPs, and they would be able to know where you are, where you go, that sort of a thing. So there are some privacy concerns just based on the data that they would be able to garner from what you're doing. And I don't know that they track it, but they will show you the type of traffic that is being sent around. And so, yeah, I don't know. I don't have any reason to doubt them, but I understand the question, and that's why I kind of want to self-host Headscale so that I know where all of my traffic is going to and from.
Yeah, mainly I was thinking of attack vectors that some other third party could use to tap into your systems. You know, something that was not considered in the design.
Yeah, and if you have, I mean, it depends on how free you are with adding devices to your network too. So Tailscale, especially if you go beyond the free tier, they have things where you can share one computer into multiple tail nets. So, you know, a computer could have a foot in two different networks. And while that's a great feature, that's opening up your tailnet to whatever other, you know, tailnet you're connected to. So if you're connected with another user's tailnet with all of their computers, you're potentially opening up your tailnet of all your computers to whatever they have. So I don't know that the Tailscale itself is representing a risk there, but they're providing you with the ability to shoot yourself in the foot.
I see. Yes. Thank you.
Sean, when you were setting up the config files on the remote end and your local end, on the local end, you had to put the public IP address of your remote end so that you could find it, right? Did you put, you didn't have to put the public IP address of your local end in the remotes config, did you?
No, once it's established, that's it. So you just have to have one computer. And that's why for me, the server client model makes so much sense in my head.
Yeah.
You know, so the server for me, while it's a peer, that's the way that I initiate the connection. And you can initiate from multiple clients into that same, you know, into that same
the remote end is waiting for a connection. The local end is establishing the connection. So you could be roaming around. You could be a laptop that's in a hotel room and connect up to your server because you know the static IP address of your server.
Absolutely. Yeah.
But your local end doesn't matter.
Your local end does not matter. No, because it reaches out. Now, and like I said, I don't know if it was clear why I set up that that persistent keep alive packet, but if you connect to your data center, like your SSH in or whatever, and you don't do anything, you're idle for a long time, and the local, like your coffee shop router kills that state, even though your computer thinks it's still connected, it's gonna break. So that's why I generally do that keep alive, persistent keep alive, just to keep that outgoing
VPN and SSH.
Yeah, same sort of thing. But it doesn't do it by default. You do have to set up that persistent.
Sure.
So Sean, once you set it up, does all the traffic go through the server, or does it go directly between the two peers?
It depends. When you set up that allowed IP on your local peer, like if I'm on my client or whatever, if I set the allowed IPs to just a subnet, you know, one subnet, then anytime I try to connect to that subnet, it's going to go through the tunnel. If I like try to connect to
So let me,
in my setup, I just had I know what I think I got it. So all my clients were going to the same thing. However, you can also have like peer-to-peer connections over here. You know, I have a server up here and these two are connected to it, but they can also connect to each other. It would just be another peer line. The problem is they might not be able to find each other across the internet. And so without having an exposed port, establishing that connection might be the tough part. So it's possible to set up a mesh, and that's something that Tailscale does incredibly well. Is it sets up all of those meshes so everybody can talk to everybody, and it'll find the shortest possible path. To do that with WireGuard requires a lot more manual configuration of, you know, what allowed IP goes to what peer, how does this peer connect to that peer, and that sort of a thing. So it has to be possible because Tailscale just uses WireGuard, but the configuration can get really complicated and change dynamically pretty quickly.
Okay.
I'm looking to see. I've got two folks asking a question. John, you seem to be first, so if you would please go ahead, unless you have already asked your question.
No, I was wondering whether you had run into any problems because we're dealing with a tunnel and reduced MTU size, and I have in using WireGuard had some difficulty with some websites and had to take some extra steps, which I'm not sure are 100% effective in order to get TCP traffic over that reduced size tunnel.
Well, I have not had that issue at all. Now, that's an issue that I really had using shuttle, like SSHUTTLE, when I talked about like a year ago when I was presenting about SSH and that ad hoc VPN. That's a huge issue with throughput because it's TCP over TCP, and that really crushes the size of the, you know, the packets and stuff. So I have not had that issue with WireGuard myself though. And my CCNA chops are rusty, so I would have to think really hard about exactly how the packets are encapsulated over the UDP connection and stuff. But I haven't, but I'm not saying it's impossible. Everything breaks.
Well, in my case, most of the time it works. I'll run into an occasional website where that's been a problem. And I've also run into an occasional problem where I'm using a Linode as my server, as you put it.
Mm-hmm.
So I guess I'm among some troublemakers, and some websites just don't want to talk to me because they're afraid I'm just going to cause them.
Oh, now that could be because of the IP range that you appear to be coming from. I guess that's
right.
That's an issue with, this is a completely different topic, but I had a secondary MX server because I host my own mail server. And so I set up a secondary MX server on, it was just a VPS that I, paid for with the static IP, but that static IP was not trusted by most mail servers because it was part of a range that the VPS, service had. And so I actually had to shut it off because it was, I would constantly get issues where my mail, I don't remember exactly the issues that I was having, but it was because it was it was blacklisted just by its own merits or whatever. So yeah, that's definitely a possibility where all of your traffic coming from Linode would seem suspicious.
Thanks.
Yeah.
You have your hand
now,
up.
I don't think you're suspicious, but
well, that's good.
Justin, go ahead.
Hey, yeah. Great talk. It's pretty interesting. I want to play with it.
Thanks.
Maybe even on like servers. Have you done any server to server stuff just for?
Yeah. So in my actual, my day use, I have a WireGuard set up on my pfSense router here at my house, and my day job is managing data centers in the Western US. So there's 5 different data centers, and I actually do all of the WireGuard connection on my pfSense router to a little VM inside every data center. And I do that so that whether I'm here at my desk in my office or sitting downstairs with the laptop on my lap watching TV, I can connect to all the data centers. So it works generally pretty well. I'm pretty happy with it.
It stays up. You don't have any problems with stability or memory
None
issue,
at all. In
like
fact,
that?
no. And when I, the nice thing is, and I don't set up any sort of keep alive stuff on my router, which maybe I should. Now that I think of it, it's just a client going out. But anyway, no, it's just always ready to go. And the VPN itself doesn't care if it never hears. You know, the receiving side doesn't ever care. It just has an open port and it just waits for you to connect. And so, yeah, I haven't had any connectivity or stability issues whatsoever. I mean, not even once in like over a year I've been using the system. So yeah, it's pretty cool.
Awesome. Thanks.
And that's, to be clear, that's WireGuard, not Tailscale. I'm sure Tailscale is great, but I haven't used Tailscale in production, especially with my job, because again, I'm paranoid and I don't know what they're doing with my data. So I didn't want to like introduce my my employer to the Tailscale stuff that I don't have complete control over. So
Yeah, for sure. That makes sense.
Tommy, you have your hand up. And now you don't. Okay.
I've got another quick question, actually, if that's all right.
okay with me.
Yeah, I was also curious if you've ever used OpenVPN or had any comparison to that to make.
Yeah. In fact, yeah, I use OpenVPN for this same job. And it's all still set up. It's like, it's just a backup now. In fact, I used OpenVPN for like 2 years, well, ever since I started this job, to connect to the data centers. And I mean, I like OpenVPN. I don't like the, you know, you have to open up multiple remote ports. And then for some reason, it just seems more complicated to set up than WireGuard, even though I know it was a lot of information kind of dumped at you. The simplicity of WireGuard is what I liked. In fact, for me, the proof was in the pudding. Even though I had OpenVPN set up everywhere, I actually took the time to set up WireGuard to connect to all of my remote data centers, because I just liked how simple and how stable it was. And yeah, so yeah, I've used OpenVPN forever. I mean, I used, my gosh, I'm old. I've, you know, back in the day, point-to-point tunneling protocol was where it was at. And then what L2TP was like the cat's meow for a long time, and IPSec, and most recently, before WireGuard, though, OpenVPN is what I used, and it's fine. I don't have anything terrible to say about it, but I much prefer WireGuard.
Awesome. Yeah. Thanks. I use OpenVPN at work, and yeah, it is a hassle, especially, I don't know if you've ever had the pleasure of configuring that on like a Ubiquiti Edge router. There's like no support for it, and it's worse. But yeah,
yeah, we use Ubiquiti Edge routers in my data centers, and I didn't ever set it up because it's not. Yeah, it wasn't worth it for me. I just port forwarded into a virtual machine inside the network, and that's what I used as the OpenVPN server, because it was such a pain in the butt to try to get it to work on the router. So yeah, I feel your pain there.
Yeah, it's terrible. Awesome. Thanks a lot.
Tommy, go ahead. Your audio is not doing anything, unfortunately. All right. Well, if your audio manages to figure itself out, let us know. Are there any other
Or you could
questions?
put it in the chat. Oh, look at that. He's put it in the chat. ... Meatball menu. That probably wasn't the question.
Probably not.
So is it meatball menu is sideways, hamburger menus, the 3 dots up and down? I think that's.
I have no idea, honestly. It's all infuriating.
Hamburger menu.
Here, so.
Hamburger menu is 3 horizontal
Up and-
bars. The 3 dots vertically are a kebab menu.
Oh, okay. Well,
I hadn't heard that.
All I know is that every single user interface thing that I grew up with has been turned on its head, and I am a cranky old man because of it.
yeah, I don't know if you heard me mention in the video, like the pound symbol or the hashtag, if you will.
Yeah, exactly.
Also known as the.
Oh, and what is the actual real name of that thing?
What was that, Wolf?
It's the Octothorpe.
Octothorpe.
Oh, the
Yes, the
Octothorpe.
Octothorpe,
Yes.
thank you.
Yes.
Yes.
Yeah. Trying to explain these different things to an 80-year-old mother-in-law trying to troubleshoot
Oh
her
my God.
iPhone.
Who's dying?
I count as one of my grand the pinnacle of being able to do phone support is getting my dad to install NVIDIA drivers on a Linux machine remotely when they failed.
Whoa.
Yeah.
I can barely do that
I
locally.
really
Oh, and they
soothe
failed?
at this point. It's
Yeah,
like, oh,
barely do it myself.
I know. Speaking of which, we have results for the board elections. And, stunning no
Yeah,
one.
I was paid to talk over the limit so people couldn't vote. No, just kidding.
No,
Yeah,
that's all right.
yeah.
Stunning no one. We have for the 6 members that were on the ballot. So congratulations to all the suckers. I mean, members, you are now part of the lovely board. So
Fantastic.
I mean, why don't you just go ahead and type your question in the chat, and I will relay it if that's possible, because I know audio, unfortunately, is real fun from time to time, especially when you're trying to do everything live. As I have done more than once, I actually did an entire role-playing game at Gen Con on Discord with my microphone completely muted, so my character was all of a sudden mute. And so I did all sorts of things to do that. I've heard of using Linode as an exit node. Okay. And self-hosting everything. All right.
Okay, so maybe there's more coming, but so the exit node terminology would imply, but then accessing services from.
Or with WireGuard. Okay.
Okay, so like combining both Tailscale and WireGuard, I haven't heard of that, but the through WireGuard, that's interesting. Unless you mean, unless you're using the exit node terminology as like the server, my example of the server setup, and the only downside of doing that is what the other person whose name I didn't see because it was off screen. You could end up with the issue that sites will see you as like being a malicious source because all of your traffic to their website or whatever is coming from a Linode IP, and so they might see that as suspicious. But I'm trying to rejoin, so he's not here, but that's okay. Okay, Al. So yeah, that is an issue that you might come up against.
One other thing you may also come up against is, the way that things happen via NAT and whatnot. I know for myself, I use SSH tunnels and such, and sometimes things are not necessarily happy on my network because certain things will think that they need to go through certain routes that aren't necessarily there. And if you don't have everything quite set up, things will get very confused, and websites that demand, demand a clear connection through the entirety of your network may get a little confused.
Especially if one of the we're trying to communicate and one is coming from this IP and half of the conversation's coming from this IP. It can that stuff can get ugly pretty quick.
Are there any other questions out there?
Yeah, can I throw one out there about Headscale?
Please do.
The multi-factor authentication. Do you have that working with Headscale?
I'll be honest, I have not installed Headscale yet.
Okay.
I plan on installing it in a Docker container, but no, I have not installed it yet. I've only used Tailscale, and using it enough, it creeped me out. So that's why I'm really interested in Headscale.
Got it. Thanks.
Al Filler writes, I was asking to see whether one can use the cheap VPS and not have all the traffic go through it. Just use it to establish the connection, then have the peers connect directly to each other, like my home and the laptop that I'm using when traveling, etc.
So I'm not positive how to get two peers to connect using WireGuard, unless they have a direct connection to each other. And I know that Tailscale does it somehow pretty fancy, but that might be part of their relay service that they use too. So I think if you wanted to do that, probably a combination of Tailscale clients and the Headscale server would probably be the best way to make sure that you're in control of all the data flow. But I don't know how to configure two WireGuard peers to connect to each other, even if a third is accessible, because they have to establish a session to each other. And even with a relay, they can't, I don't have a great.
Yeah, I think that's what Tommy was asking too, was like use the cheap fund.
Yes, Tommy, we hear you.
Set it up that way.
Oh, hi. I got my big fancy headphones did not work, but my Bluetooth guys do. But yeah, I don't know. I haven't really heard much about it. I thought, I heard you can like have your home lab all hosted, and you can just like tunnel everything through a Linode, and you can have like 10 or so endpoints on the Linode, and a lot of it just makes home lab stuff like super easy.
So so that would be like your public IP would be the Linode for
exactly.
the services. Okay, so before I got like I have like a static IP range and stuff at my farm. Before I set that up, I had tried using a VPN to do that, and I was never happy with the performance. But what I did is I would poke holes in my home network where my home lab was and just set up a reverse proxy on the Linode style server. And so it would know, the reverse proxy. I love Caddy server. If you're not familiar with Caddy, it's just such a great program. It does reverse proxying really well. So you would have to like set up dynamic DNS or whatever in your house. But I had really good luck with that because the outgoing establishment of VPN and then have that as your front end. I never got it to work reliably. Yeah, I got it to work, but never super reliably. I got it to work just as well with SSH tunnels as I did with VPN. The problem with SSH tunnels is TCP over TCP. So you get some serious throughput issues when it has to do packet retransmission and stuff. So, I mean, that should work. You would just have to set up, you'd have to do like some fancy routing of packets. I don't know. I have to think hard, but I mean, it's definitely possible to do.
I have edge workers and stuff like that. So I'm like web developer, and I've seen that's like the realm in which I've seen it. I've seen like things. I don't know. I wasn't really prepared. I could have like dug up some about this, but it's like Kubernetes endpoints and stuff. Everyone's been like talking about. I don't know, it's like Cloudflare. Cloudflare's got this like new endpoint thing that they're doing, but I think it all uses WireGuard like under the hood, and
that would make sense.
Yeah, but it's like all this. I don't know. It's like I've seen all this hoopla about it, but I just haven't taken the time to look into it further. But it's I've been using Tailscale personally for I don't know, like a month or so. I went on vacation in Vegas and I was watching my DVD collection. Worked out pretty well.
It's
but then
creepy
also
how well it works.
yeah, but like even Tailscale has like a whole bunch of like weird endpoint features that they're like are in beta now, and it's like you can sign up for. And I don't know. If I find that I don't know. It's not like in my direct vision, but it's like I bumped into it in the past like month a bunch, and I just can't remember what it's called or anything. But I don't know.
It wouldn't surprise me that that stuff is using WireGuard under the hood because again, WireGuard is so simple in how it does stuff, and once it's configured, it's just rock solid. And so, however they configure it, yeah, that'd be cool. I could see that being an awesome way to avoid having to set up reverse proxies because again, that's the way that I did it before I got the data center. So
Richard Jackson, you've been very patient. Would you like to ask a question?
No, I just wanted to mention that in the chat, there have been a few questions. And so I wasn't sure whether he had answered them.
Did I?
I'm not seeing anything that hasn't been addressed. Is there one that we haven't?
So the questions from Tommy. Tommy did get his microphone working. So
right, yeah.
Okay, all right. I'm sorry.
But thank you.
No worries. Thank you.
That.
We appreciate it.
Because if you know me well enough, me missing something is very, very likely to be the case.
Well, it made me also wonder if there was something that I missed too. Are there any other questions or comments or? A reminder too that we also have our comments form link in there. So if you would please present your comments. You also have the ability to edit comments if you'd like to do so. So, Nick, you have your hand up.
Yeah. Okay. So I'm gonna re-ask my question in maybe a better way from before. So my ultimate goal originally with Tailscale was to force my phone to push all of my DNS traffic to pfSense, primarily for ad blocking. I was finding that the ads were just running my phone crazy. And I thought originally that only pushing through the DNS traffic would sort of be better because I wouldn't be tearing up so much mobile data, and maybe the performance might be a little bit better rather than pushing everything all the way home. And like I said before, I wasn't able to get that working through the Tailscale interface, but maybe it would be better if I were to set it up just through WireGuard. So is there maybe a way that I can just force DNS traffic through that connection with WireGuard?
Oh, I'm not sure. I mean, you can set up DNS stuff, but I'm not sure if when you set the allowed IP to just the tunnel interface, and you don't do like 0.0 so that all of your traffic goes through the tunnel, I don't know if it will still use the DNS. I would definitely try it. The other thing using Tailscale, if you have Tailscale installed on your DNS server proper, like is it actually the same IP address or the same computer? You said pfSense, so I wonder, is it running on the pfSense?
Yeah. So I'm just running pfSense, and I originally had installed the Tailscale package, but there's also a WireGuard package which I never specifically set up, but there's no reason I couldn't.
Right. So, but before you do that, I know that pfSense locks down all traffic via firewall really hard. So even if you have Tailscale installed, like you can't ping your pfSense, even your tailnet IP address, you can't ping it because the firewall on pfSense is still firewalling off that interface just like any other interface. So you might have to make a firewall rule that would allow your tailnet to query your DNS server. So that might be part of the issue too.
That's interesting. I did find one post somewhere that said that you had to specifically add the IP address of the node or whatever in the allowed hosts for the DNS server. But I believe there's also some weird, again, I think there's some kind of weird routing because it runs in user space, and even the firewalls don't. It's routed weird. Apparently, once the traffic hits pfSense, it's considered local, and because of that, the firewall rules don't all necessarily apply the way you would assume they would, because it's not considered remote traffic. It's considered local traffic. It gets goofy.
I believe that it makes it tougher to figure out what's going on.
Very confusing. I don't really know what to do with it.
I would bet though that the DNS could eventually work if the firewall, figure out exactly what is blocking it and how to open it. I bet that would work. Because like I said, out of the box, ICMP ping traffic is blocked. And so that would be a good way to test it though, is you could, on your pfSense router, try to get pings to work. And if you figure out how to open it up so that you can ping your tailnet IP address on the pfSense router, then whatever firewall rule you had to set, you could also set one up to allow, port 53 traffic. That would be how I would troubleshoot it anyway.
Okay, hadn't considered that. That might be a good place to start. Thank you.
Yeah.
Sorry, I was trying to find the Zoom window.
Very interesting, Sean.
Oh,
Well, thank you.
Jim has one
fun.
question.
Yeah, I just had a suggestion there. I'm not running pfSense. I'm using Tomato software on my router. And I just redirected the DNS queries to go to another IP on my LAN, which is running Pi-hole on a Raspberry Pi. And that works very well for getting rid of all those ads on Android.
Yeah, for sure. Out and about though, that would be the, I'm guessing that was the issue, is when you're out, on like LTE, trying to still utilize that internal DNS that has stuff blocked. That would be I assume that's what Nick was trying to accomplish there.
It also depends on your browser as well, because I know I don't have port 53 forwarded at all, but I use Mozilla's and Ubuntu's proxies, and it seems to go through and do all that stuff over the regular SSH tunnels that I have. So that may be something that's also in play as well if you're out and about. Depending if you decide to use a proxy or whatnot. I use just a really basic proxy for all that stuff.
The other thing, another thought for Nick, if you have something like Pi-hole on your internal network, you could probably install Tailscale on that, and you wouldn't get the weird firewall issues that you get with pfSense. As much as I love pfSense and I use it, you might be able to directly query that node, or that tail IP, whatever they call it, tailnet IP. But that's just, again, more troubleshoot thinking in my head.
Yeah, Pi-hole does support natively WireGuard. So you can create a WireGuard instance on there, and then you can connect to your local network through
and probably
LTE or whatever.
Probably Tailscale too, I would assume.
Yep.
Any other questions? Oh, sorry. Go ahead.
Oh, sorry. Just a quick follow-up to everyone's point that you were just talking about the DNS. I think you're absolutely right. I think this is a pfSense general issue. And I have actually started to consider the idea of just using a Pi-hole, because I'd have a lot more control specifically where that traffic is going. Because right now I'm really guessing, and a lot of it isn't really logical in the first place. It's kind of, that package seems really hacked together. It works, but just. Yeah. Good suggestions. Thank you very much.
Tommy, you have your hand up?
Yo, yeah. Have you heard of this NetMaker? NetMaker.io?
I have not.
It's first time seeing of it as well.
NetMaker,
yeah,
NetMaker, make me net. No,
I don't know. I had a client who was talking about it. NAT, firewall, subnet. I don't think that I'm like looking for this article. I know I got it somewhere. It's driving me crazy, but I found this too. But I had a client talking about this.
No worries. We have an afterglow. Afterwards. So, if there's no other questions, I'd like to thank Sean for coming out here and spreading the gospel of WireGuard and whatnot, and making me rethink my entire SSH tunneling.
Yeah.
But yeah, thank you so much. We really appreciate it.
Yeah, thank you everybody for listening. I don't get to talk to other nerdy people all that often, so.
Oh, that's a shame.
Well, it's nice to have you.
Fun.